Okay, so this is section 8.5, and the name of the section is the law of sines and the law of cosines. Okay, so this section is one of those sections that not many people would be able to tutor you, help you with, okay, because it's one of the sections that teachers usually skip and they don't cover it. But it's not that complicated. See, the thing here is that we need to cover this section because we already study all the right triangles. You know, finding missing angles, missing sides, using the Pythagorean theorem, using the, which is the one that you like a lot.
None of them.
Which is the one that we use a lot that has an acronym? The SOHCAHTOA. There you go. You know, sine, cosine, tangent. And the third one is when you use special right triangles. Which are the special right triangles? 30, 60, 90, 45, 45, 90. There you go. So if you're missing some sides or angles in a right triangle, you can rely on those three things. Okay? Now, but what if the triangle is not a right triangle? And this is why we need to learn the law of sines and cosines. The law of sines and cosines allow you to find missing sides and angles of any triangle, right triangle, obtuse, acute, okay? So when you're looking for missing sides of acute or obtuse triangles, the law of sines and cosines will help you to do that, okay? So now, the first thing we need to do is to practice with a calculator. Let's go ahead and get the values. It says you can use a calculator to find ratios for obtuse angles. So let's go ahead and do the first one, which is the sine of 115. So just so that we make sure that we know how to use a calculator. So press sine. Yes, we have to change, make sure we're in degree mode. Yes. This does not project. Okay. God bless you. So did you get a sine of 115 equals to the 0.90637, just to double check that your calculator is in the right mode? Yes? Okay. Once we do that, now let's go ahead and get the values of the first three problems. So let's go ahead and get using the calculator, let's find cosine of 104, cosine of 104. So what is the value of cosine of 104? There you go. So notice that here we're getting negative values, and that would be okay. So it's negative, and this is to the nearest hundredth, right? To the nearest hundredth. Let me use another color. And let me use a thicker. Okay, where's the thicker? Capacity. Okay. Let me just adjust this. Okay, so here we have negative 0.24 when it's to the hundredth place. Okay, now how about tangent of 225?
1.
It's just 1. That's right. And how about sine of 100? 0.98. Okay, so it's 0.98. So 0.98. So notice that sometimes we're going to have negative decimals, whole numbers. The whole number is going to be just 1, by the way. Or decimals like 0.98. Now, what if we need to find missing sides? So let's go over the first, let me just undo. The first property. See here, and let me select one of those tools. As you can see here, let me change stylus because this is not really working that well. Okay, so notice that here we have sine of A over A equals to sine of B over B, and that is equals to sine of C over C. So when you have two angles, because this is an angle, A and B are angles, when you have two angles, and you have two sides, if you remember, the side A, lowercase a, is across from the capital vertex A. and then lowercase b is across from the vertex capital letter B, and then the C, lowercase c, is across on the vertex capital letter C. So you're always going to find the side across from the angle corresponding to that angle. So if you have two angles and two sides and you're missing one of those four, I'm sorry guys, you're going to have to use the law of sines. So if we do that with example number 1, over here in this section, so it's problem number 4, it says find each measure. Here they want us to find the measurement of angle of TU. So this is what we need to find, TU, this one right here. Since I need to find the side TU, I'm going to let this be X. Well, notice that that angle across from that side is given. And then we have another angle in which the side across from that angle is given. So if you have an angle and a side across given, and then an angle, and then another side across, in this case we're missing that one, here we can set up a proportion. And we can say, well, sine of 84 is to X, which we don't know. 64? It looks like an A, right? But I'll go with you, 64. So sine of 64 is to X, as then is sine of the other angle, which is the other angle? 41 is to, that's an 18, right? 18, great. So at this point, it's a proportion. So what we can do, we can just cross multiply. And as you remember, you always put the bottom number first. So I'm going to put the 18. And then you put the property, sine of 64. Equals, and then you put the bottom number, this is X. And then you put the property, which is sine of 41. Since we're looking for the X is multiplying by sine of 41. So what's the opposite of multiplying by sine of 41? Dividing by sine of 41. And that's going to give us the value of TU. So let's put that in the calculator. Now what you need to do in something like this is either use the alpha y equals and then number 1, and that would allow you to get the calculator in a fraction line and then number line and then line number. So did you find that? Alpha, press the alpha key, the green one, and then y equals, and then option number 1. Do you have it in fraction form? Yes? Okay, perfect. So let's go ahead and put 18 sine of 64, close parentheses, and then let's go to the denominator and put sine of 41. And now press enter. So what did you get from there? 24.65. That is right. So it's 24. It's 66, no? Right, but degrees would be to the nearest degree, you know, the angles. But remember that the sides of the lengths of the sides are always going to be rounded up to what? Always to the hundreds. It says to the tens, but we're going to round out to the hundreds to get used to at least 2 decimal places, okay? Because on the next problem, we're going to round out not only to the hundreds, but we need to round out to the thousands, okay? And I will tell you when to do that. But here, at least to the hundreds place, to be more accurate, okay, on the measurement. So this is going to be not 6.5, but it's 6.66. That's right, okay? And that would be the measurement of that side length. So if you have 2 angles, and then the sides across, you know, either are given or you're missing one of those 2, then you use proportions for sine, you know, law of sines. What is that, Carlos? So far, so good? Yeah. Okay, perfect. Okay, so now problem number 5. In problem number 5, it says, find the measurement of angle E. So notice that here, I'm going to use a black color. Notice that here, you have an angle given, and the side across from that angle, it's given. Now, let me see if I can erase. I don't know if I can erase that. No, I cannot erase. Okay, but see the angle E, it's right here. And the side across from angle E, it's given. That is 26. So we can set up a proportion using the law of sines. So if I set it up, I can say, well, sine of E, the angle that I'm looking for, is to, what's the side across from the angle E? 26. As sine of the other angle, how much is the other, how many degrees is the other? Of 102 is to the side across from that angle, which is 42. Okay? And now at this point, we can just cross multiply. I was writing the bottom part first, so this is 42 sine of E equals, and then it's 26 sine of 102. Okay, so see the thing here is that E, it's an angle, and you cannot just divide by 42 sine, because to get rid of the sine that is right next to the E, you get the inverse sine. Remember that? Every time you're looking for an angle, it's inverse and then the property. So I have to get rid of the 42 first. So let's get rid of the 42, that is multiplying the sine of E. So what's the opposite of dividing? So we have to divide both sides by 42. Okay, that will be cancel that out. And now, next, I need to get rid of the sine. So let me just bring this up. So let me rewrite this, okay? So this is going to be sine of E equals, and then I'm just going to rewrite the whole thing. See, I'm not getting the value yet, because if I get the value and I get an approximate answer, my answer is not going to be as accurate. So now we can go ahead and get rid of the sine. So how do we get rid of the sine? Inverse sine. So put in parentheses and get the inverse sine. That way you can cancel the sine with the sine. So the measurement of angle E equals, now go ahead and put that in the calculator. You're going to put arc sine and then parentheses second sine, and it gives you parentheses right away. And then you're going to put 26 sine of 12, close parentheses, and then divided by 42, and then close parentheses. I have 7.39. Yes, so you gotta be careful. Let me repeat the instructions. You gotta press second sine, and it gives you parentheses. Then you put 26 sine, and when you press sine, it gives you an open parentheses. You're gonna put 12, and then close that parentheses. Okay, and then after that, you're gonna divide that by 42.
This is 102, not 12.
Is 102? Ah, that's what it is. Okay, so 102. Let me go over and let me change that. Thank you, Samantha. So 102. So let me go back and put that number. Second insert 102. So it's not 7 degrees, right? It's what? 37 when you run it to the whole number. Double check a second sine. So this is 37 degrees. Right, it says 0.26626, but degrees are rounded to the nearest whole number, nearest degree. Nearest degree, nearest whole number. So lengths of size, nearest hundreds, but degrees, nearest degree, nearest whole number. Okay? Everybody okay with problem number 5? Yes. 37. Okay, second part.